Hi guys, welcome to lesson 6.7, Congruent Triangles. So in review, we've been talking about side angle side congruency and angle side angle. And basically what these say, well, we know that corresponding parts of congruent triangles are congruent. So with side angle side, we have two triangles that have corresponding congruent sides and an included congruent angle. So side angle side congruency shows that these two triangles are congruent. With angle side angle, we have two angles of each triangle that are congruent and the included side. So we have angle side angle. When we have this pattern, we have two triangles that are congruent. This lesson we're going to be learning about side angle angle, and what that says is we have two angles and a side. And this time the side is not included. When it is included, it's angle side angle. When it's not included, it could be this one or it could be this one. We have side angle angle, and that also shows that we have congruent triangles. All right, I want to get a fresh piece of paper here. I want to go over example 1 with you on page 246. It's showing us how to do a actually, you know what? Let me take a different one because that one's pretty self-explanatory. Let's do example 2. All right, so here's example 2. It's on page 247. And we have overlapping triangles. So I'm going to go ahead and draw this stuff on here. First, I'm going to write out my given. And this is how you'd set up any proof. You write out what's given. We have angle A is congruent to angle D. And angle ABC is congruent to angle DCB. And they want us to prove that segment AC is congruent to segment DB. And this is what our diagram looks like. And we have A, B, C, D, E. So the first thing I'm going to do is I see that I have two triangles here that are overlapping. So I'm just going to redraw this to make it easier to see. And because this is what they want us to do, you know, because it does make this easier to see. Sorry, my screen is going all over the place. I'm trying to look over the screen and see my paper. So this over here is triangle ABC. I just drew this part over here. And now I'm going to draw this part here. Bye, sweetie. All right. So as you can see, Stephanie's going off to college and Mandy just left too. So we've drawn BC twice. It's the same line. So I'm just going to mark that as being the same. Okay? All right. On to my proof. Angle A is congruent to angle D. So I'm going to mark that right now. I have angle A and angle D. And that was given. Number 2, I have that, I also have, sorry, I didn't put this in there. Angle ABC is congruent to angle DCB. So ABC is congruent to DCB. All right, well, guess what? That shows me, let me do my other one. Number 2, BC is congruent to BC. Actually, let's just say it equals itself because it's the same line. So we'll put reflexive property. So when I look at this, I have angle, angle, side, or side, angle, angle. That's the way they're doing it. Side, angle, angle. We always did it angle, angle, side, so we'll just do side, angle, angle on this one. Since I have that congruency, I know that triangle ABC is congruent to triangle DCB by side angle angle. And if this triangle is congruent to this triangle, then their parts are going to be congruent. So then I know that AC is congruent to DB. So I can just write that down. AC is congruent to DB. And that would be corresponding parts of congruent triangles are congruent. All right. The last thing I want to show you guys has to do with what they call an auxiliary ray. Sometimes when we're doing proofs, we're going to have to, we always used to call it dropping a, we would just like drop a perpendicular line. And I'll show you what that does. So like in your next proof, you guys have an isosceles triangle. Well, for an isosceles triangle, we know that these two angles are congruent to each other and these two sides are congruent. You can drop a vertical. It's a bisector. This would be equal and then these would be perpendicular. So then you could get your angle side that way. Okay? So yeah, you're just dropping a perpendicular line down here. And the definition of perpendicular states that when you have two lines that are perpendicular, they form two 90-degree angles. So that would give you the angle that you need. And I'm just going to cross that off for angle side. And that's it.